Let's return now to the question of characterizing the frictional force of the platform acting on block B. So before we return to the options for the answer to this question, we want to think about what the frictional force does. So first of all, it's a non-conservative force because it dissipates or changes the form of energy, of kinetic energy, into another form, and in a way that you cannot then retrieve that energy and produce kinetic energy again, as a spring would do. So it's a non-conservative force. And also, it's internal to the system, since it corresponds to the action of the platform on block B, which both are in the system. So because of that, we can then look at our answers here, the possible answers, and notice that A and B pertain to external forces, as we've mentioned. And the kinetic frictional force in question here is not external to the system, but it's internal. So we can rule out A and B. C and D pertain to internal forces that are actually conservative forces as well. And so they have to be out as options. So finally, the only option we're left with is none of these. And in fact, what the kinetic frictional force does is convert kinetic energy of block B into heat. So as block B slows down because of friction, that kinetic energy then is transferred into thermal energy. So let's look at another question. Let's characterize the effect of the weight of block B, or the Earth acting on block B. So take a moment to think this one over, and then we'll return and answer this one.